Hi there. We're going to talk about sections 3.1 and 3.2, and then I'll do another video for 3.3, even though all of these are on the same assignment. So, as a review of graphing, looking here, we have a coordinate system, and we have quadrant 1, then we go counterclockwise, quadrant 2, quadrant 3, and quadrant 4. This should be a review for most of you. Here, the plus and plus just means that the X and the Y coordinate are both positive in quadrant 1. Here in this quadrant, the X coordinate is negative and the Y coordinate is positive. Here in quadrant 3, and notice we're using Roman numerals, this quadrant, in this quadrant, the X's are negative and the Y's are negative. And over here, quadrant 4, the X's are positive and the Y's are negative. This right here, this line is called the x-axis, and this line is going to be your y-axis, and right here at 0, 0 is the origin. Now, when they list ordered pairs such as this, 2, 3, and -5, 4, I apologize, it's not real focused. These are always in alphabetical order. So here, this is going to be your X, and this is going to be the Y. Now, if for some reason you're using A's and B's in your equation, the A would be first, the B would be second. So these are always in alphabetical order according to the variables that you have in the equation. So in order to graph this, you would go 2 on the X, 3 on the Y, it would be in the first quadrant. So going up here, you'd go 2 on the X, 3 on the Y, and your point would be in this first quadrant. This one, -5, 4, -5 on the X, 1, 2, 3, 4, 5, 4 on the Y, and up 4. I don't have a 4 up here, but it would be in this second quadrant right up here. So these are called ordered pairs. Now, interval notation. Some of you may have seen interval notation. If you haven't, that's okay. We'll be talking about it later extensively. The thing is that interval notation looks like an ordered pair, but interval notation just means numbers between like 2 and 3. Or numbers between -5 and 4. So interval notation and ordered pair, they look alike, but you'll know which one you're doing according to the problem. They'll tell you, write this in interval notation. You'll understand that later. So here, again, you can plot the point, -3, 4. Just like in the game Battleship, you'd go -3 on the X, 1, 2, 3, and 4 on the Y. 4. Let me make sure I have that right. 1, 2, 3, -3, 1, 2, 3, 4. So there's your point, -3, 4. Okay. All right, pretty simple. No problem. All right, let's go to the next page. Here, graphing equations, the basics. What does an equation look like? It doesn't necessarily have to have 2 variables. It can have 1 variable. So we'll be graphing equations that have either 2 variables or 1 variable. But an equation, as opposed to an expression, an equation has an equal sign. So when we have an equal sign, we've got us an equation rather than an expression. So let's look at this next part. For an equation containing 2 variables, the solutions are ordered pairs. So here's an example right here. All right, I've got an equation. It's got an equal sign, 2 variables, A and B. When you solve this, you're trying to find numbers that you can put in for A and B and have the left side equal 22. That's the goal. Now, let's see, each number replaces a variable. If the variables are not X and Y, the letters that come first in the alphabet is the first coordinate. So if you're given something like this, 2 and 7. The 2 will be the A in the equation, and the 7 will be the B. So let's read this example 2. Determine whether each of the following pairs is a solution. In other words, does it work? So looking at this first one, we would take 4 times 7 minus 3 times 2. This is the A, this is the B. In the equation, when they're next to each other, you multiply, equals 22. Is that true or not? But my equal sign's a little there. So here you multiply PEMDAS. If you have a calculator, and that's fine, you can use a calculator. You can, you could just plug this into your calculator, and sometimes they'll just do PEMDAS for you. So we've got 28. You multiply, then you subtract, and so it works. And so this would be a yes. 2, 7 is a point on the line. If you were to graph it, 2, 7 would work in that equation. So we call it a solution to the equation. Notice that the solution, when you have these two equations, is an ordered pair. Let's look at this next one. Is 1, 6 a solution to this equation? Or if you were to look at the graph, a graph is a picture of the solutions. Does this point fall on the graph? And the graph is a picture of all the solutions. Let's look. We take 4 times 6 minus 3 times 1. Does that equal 22? Okay, this is the A, this is the B. So here, following our PEMDAS, we're going to multiply and then we'll subtract. So we have 24 minus 3. This right here is 21, which does not equal 22. So if you were to look at the graph of this right here, this would not fall on that graph. This is not a solution. So the answer is no. Okay. All righty. Let's look at another example here. Example number 3. Determine if 3, 7, 0, 1, and -3, -5 are solutions to this equation. Well, we have, this is 7 is the Y and 3 is the X. So we have our X and our Y. So substituting these in, first off, I'm going to copy it. 7 is the Y. 3 is the X. So we have 7 equals 6 plus 1, multiplying. And again, I just substituted these in from the ordered pair that we're looking at. 7 equals 7. That's true. 6 plus 1 is 7. So yes. This is the solution, one of the solutions to this equation right here. Let's look at 0, 1. This is the X, this is the Y. So here I'm going to copy the equation down. All right, we put in 1 for the Y. The X will become 0. So 1 equals 2 times 0 is 0. 0 plus 1 is 1. 1 equals 1. Sure it does. So this is yes. This also is a solution to this equation. Let's go ahead and do one more, just in case. I know, again, you guys can just, if you've got this, fast forward it if you need to. But if not, you have another example. So we've got X and our Y. So our Y is -5. X is a -3. So looking at this, we have a -5 equals 2 times a -3 is a -6. Oh, wow. So -5 equals -6 plus 1 is a -5. So the answer is yes. All three of those points, if you were to graph these, all three of these points would fall on the graph of that equation right there. So let's go ahead and we're going to plot the solution. We can plot the points to find another solution. So we're going to plot these 3 points, and then we'll talk about the graph. So let's see, we've got the point 3, 7, 1, 2, 3, 6, 7. We have the point 0, 1. Here's 0. So again, this is our x-axis and our y-axis. 0's at the cross there. 0 on the x, 1 on the y. Let me go ahead and write the points in. So this is 3, 7. This is the point 0, 1. 0 on the x, and then you go up 1. And we have -3, -5. 1, 2, 3, 4, 5. -3, -5. And I do not have I don't have a ruler with me. I'll just have to use maybe a piece of paper folded. You'll have to excuse me. I do a makeshift ruler. Okay. Okay, so if we were to line these up and then connect the dots, we call this a linear equation because when you graph the solutions, they form a line, thus linear. And y equals 2x plus 1 is a linear equation. All right, so and we'll talk about when it's not a linear after a bit here. And the line is the graph of the equation. What this is this is a picture of solutions that work in here. So when you graph an equation, you're graphing the solutions that will work in that equation. So every point on the line is a solution. So you could find another solution as long as your graph is relatively accurate. You could find another solution that would work in that equation, such as -2, -2, -3. Yes. All right. So if you were to put a -2 in for the x and a -3 in for the y, it will be a true solution. It would work. Or the point 1, 1, 2, 3, 1, 3. Again, 1, 3, which happens to cross the grid, would also, if you put 1 in for x, 3 in for y, it's a true solution. So this represents the solutions to that equation. All righty. Now, let's see. They want us to compare y equals 3x minus 1 and y equals 3, oh, excuse me, yeah, and y equals 3x minus 1. I don't think we're going to look at that one right now. We'll look at another example here. Okay, what we're going to look at now is we're going to look at some different methods of graphing equations of lines. All right, we have 3 methods that we're going to use. It depends on how it's presented to you, which one you're going to want to use. If you look at this first one right here, y equals a -3x plus 1. This is what we call the point slope. Well, no, it's the slope intercept form. So this number right here is where it hits the y-axis. So you would go up to the 1 on the y-axis, the slope intercept method. And then the number in front of the x, and again, this should be a review, is the slope of the line. So this actually, we use the letter B to represent where it hits the y-axis. Really, the only mistake that I see students making is that they'll put this on the x-axis. So, you know, you don't want to put the 1 on the x-axis. Just make sure it's on the y-axis. Okay, now this -3 is the slope of the line. Now the slope is a path from point to point. The point that you're going from is this 1 right here. So from the 1 where it hits the y-axis, your slope is a -3/1. So the slope does need to be a fraction because it's, you know, it's a path, it's rise over run. So because it's negative, we're going to go down from the 1. So this is the rise, and this is the run. Now, if it's negative, I usually go down. If it's positive, I go up. And then if you're using this for your positive or negative, the run always goes to the right. All right. So, I mean, you could go up and to the left, but we're going to go down and to the right. You don't want to go down and to the left because that means you have a negative over a negative, which is a positive. So one of them is negative. So here we'll go down and then we'll go to the right. So from the 1, you're going to go down 3. 1, 2, 3. 1, 2, 3. And then over 1. So you only need 2 points to determine a line. So if you were to connect those up, you have a picture of all the solutions that would work in that equation. You could pick a point and put it in for x and y, and it would work. So that is one method for graphing. And, you know, it's... Okay. So that is using the slope-intercept form of the graph. All right, now another method for graphing is going to be to use a t-chart. All right, and a t-chart is mentioned up here. How could I get this same with a t-chart rather than using the slope-intercept method? Now a t-chart, some of you may have used this before. All right, for a t-chart, you pick a couple of different x's, or you can pick a y and solve it for the x. Let's pick a couple of x's. Let's say x is 0, and let's say x is 3. I don't know if that will show up on the graph. We'll do 2. Yeah, that'll work. And again, they can be anything you want. I just chose 0 and 2. So if you were to put 0 in for this x, what does the y equal? So I'm hoping this method kind of looks familiar to you. So putting in, I'm going to copy it right here. If x is 0, -3 times 0 plus 1. -3 times 0 is 0. Y is equal to 1. So I have my ordered pair 0, 1. Y is 1. And again, we usually write that as 0, 1. Now we're going to do the same thing with the number 2. We're going to put 2 in for the x, just like we did the 0. And what I'm going to do is I'm going to get a piece of scratch paper because I don't want to interfere with some of my other problems here. So what I'll do is I have 0 equals, I'm going to copy the equation, and now I'm going to put in the number 2 in for x. So y equals -3 times 2 is a -6. So when x is 2, y is a -5. So I have the equation I'm going to come in. I have, sorry, the ordered pair 2, -5. And I would plot those. I would plot those 2 points and connect them up. Well, the first point, 0, 1, 0, 1. We got that from the y-intercept. Okay, so that worked. But the other one, 2, 5. Let's go 2, -5. This one right here. We would go 2, -5. 4, 5. My graph was a little off. And it happens to be, it needs to be the same line, but then you would connect up those 2 points and it forms the same line. So those are 2 different methods of graphing an equation. All righty. Now, the next method that we're going to look at is in the next section 3.3. So we'll talk about that method in section 3.3 in the next video that I'll do. Now here, we're going to kind of skip to what happens if, let's review here. What happens if I change the exponent on the x? Now, if the exponents are 1, it's linear. All right, the equation is linear if you're adding or subtracting, and we'll look at some examples in section 3.3 that'll kind of clarify that. But what happens if it's squared and it's not a 1? What does the picture of the solutions look like? Now, we'll be graphing more of these maybe in chapter 6, but for right now, we're going to look at a basic one. You have this -5. So what we're going to do is we're going to go down to a -5. 1, 2, 3, 4, 5. Okay. This point right here is actually the vertex. Now, we need a couple other points when you want to graph this. So we can go ahead and we're going to use a T-chart for right now. And later on, we'll learn some different methods. But for right now, we're just going to look at that T-chart. And we'll talk about this. Let's go ahead and put in 0. Let's put in 1. Let's put in a -1. All right, and see what we come up with. First off, if we put in 0, all right, we have y equals 0 squared minus 5. So I am putting in 0. Sorry about that. Okay, I'll just leave that there. So we have y equals 0 minus 5. Y is a -5. That's where I got that point right there. 0, -5. Okay. Sorry about that. There. Let's put in the point 1. All right. So to get this point 0, -5, let me write it as an ordered pair. 0 on the x, -5. Now let's look at a 1. Let's put in 1 and see what happens. So let me copy the equation so that I don't lose people. And some of you may have had this before, some not. So we'll go through it slowly. I put in a 1, and I put those parentheses for a reason. You have to be very careful when you substitute in a negative. You'll need the parentheses. So I just went ahead and used the parentheses whether or not it's a positive or a negative. So here, y equals 1 squared is 1. -4. Okay, -4. So we have the point 1, -4. When x is 1, because I substitute in an x, we get a -4. So let's plot that. 1, 2, 3, 4. There's our point 1, -4. Now we're going to put in a negative, and you're going to see why I have parentheses. It's very important that when you substitute in a negative and this power is even, that you use parentheses, especially if you want to rely on your calculator. So if you were to type this into your calculator like this, you'll get the wrong answer, because what it's doing is it's squaring the 1 and then it'll take the negative later. We need to make sure that it's squaring the negative as well as the 1. So when you do substitute in a negative, make sure that you use the parentheses if you're going to use your calculator. So we're going to put in a -1 because that's the point we chose. Notice that I chose a, well, never mind. We'll get to that later. Here, we'll put in y equals -1 squared means a -1 times the -1, which is a +1, which gives us a -4. So it just so happens that when I put in a +1, I get a -4. And when I put in a -1, I also got a -4. So the picture is going to look different. It's not going to be a straight line because we have this exponent on the x. It's no longer to the first power. So the power tells you what the picture of the solutions are going to look like, which is kind of neat. So we'll go to a -1 and go down to a -4 and plot our point. So what happens is you end up with something that looks like this. Okay, this is called a parabola. All right, you always get a parabola, so a picture that has this kind of a shape if your highest power is a squared or if it's even. So again, that will be the basic shape if this is an even number here. We're just mainly going to do the squares. The only time it might change a little bit and look a little bit different for our purposes is if I have a -x² minus 5. Now, what happens if I put a negative in front of that x² rather than having a +x²? Well, what happens is when you put in 0, you get a -5. Okay, so you come down to it. -5, 1, 2, 3, 4. Because of this negative here, it's upside down. It's an upside down parabola. The shape is the same, but it flips it over. All right. Well, kind of an introduction of parabolas there. I think that's all we have for this section. And then I will do the section 3.3, where we're going to look at another method of graphing. This was the T-chart. We use the T-chart for this one. We use the slope-intercept method, and we also use the T-chart. We can come back and look at this one in 3.3 when we talk about our third method. Again, the T-chart always works. And then depending upon the equation that's given you, whether or not you'll want to use maybe the x and y intercept method, which we're going to talk about in 3.3, or the slope intercept method. You just have to decide which is easiest for you. All right, I guess that's all. Bye-bye. Let me figure out how to stop.